Hey guys, welcome back to one more video on the channel. And this time I'm back with a really interesting problem. So, I was scrolling one of my social media accounts and I found this particular problem. So, this problem is taken from MIT Integration B 2026 and it is one of the qualifying problems. So, the problem goes like this. So, you have to compute this particular integral. So you have all these six different things and then you have to sum them up and you have to integrate that from 0 to 1000, and this is your ceiling function. Uh, so which is same as the least integer which is greater than the given number. So 1.5 is the given number, I mean like the given rational number, I would say. So the least integer which is greater than this is 2, and this is your greatest integer which is less than the given number. So this is simply floor function, floor of 1.5, floor function or step function as you may call it. So floor of 1.5 is 1, and this is your fractional part function. So you have to take the fractional part here. So like you will take the given number and subtract the integral part of that number, and then you will get the fractional part. So I know that you all know this, but just for the sake of defining the question, I'm just mentioning all these things in the beginning. So let us forget about the lower limit and upper limit of the integral, and let us forget about the integral itself. So let us see and understand what these terms are. So let us say your x lies between n and n plus 1. In this case, what happens? So let us say n belongs to some natural number. So your x is a decimal, all right? So in that case, let us analyze what happens to each of these terms. So the first term is floor of ceiling of x. So first you have to get the ceiling of x, and that will be n plus 1, and then you have to compute the floor of that, which is simply n plus 1. All right. So now let us proceed to the next term, ceiling of floor of x. Ceiling of floor of x. So in this case, floor of x is n, and the ceiling of that will be again n. All right. Next, let us go to the third term. So it is simply floor of fractional part of x. Floor of fractional part of x. So that is, so if you observe, so this fractional part of x, so fractional part of x always lies between 0 and 1. All right. So this is the fractional part of x. And now if you take the floor for some quantity which lies between 0 and 1, so what will happen? It will simply be 0. So therefore this quantity is always 0, and we are not checking at x literally is equals to n plus 1 and is equals to n, because so when you are dealing with integrals, so values at specific points does not really matter. So now let us go to the fourth term. This is the fourth term, fractional part of floor of x. So fractional part of floor of x. So the floor of x is n. All right. And the fractional part of n is, so nothing, it is 0 again. So now let us go to the fifth term, ceiling of fractional part of x. Ceiling of fractional part of x. Again, we know that fractional part of x lies between 0 and 1. So if you take ceiling of this particular quantity, you will get 1 all the time. Now let us go to the final thing, fractional part of ceiling of x. Fractional part of ceiling of x. So what is this? Fractional part of ceiling of x. So ceiling of x is an integer. Fractional part of an integer is 0. All right. So this is what we have. So now what you can do is you can split this integral. So the integral is from 0 to 1000. So you can write it as 0 to 1, 1 to 2, plus and so on, plus 999 to 1000. All right. So now what happens to this sum? This is n plus 1 plus n, that is 2n plus 1 and plus 1. So that is 2n plus 2, where n is the lower limit of your integral. So here what you'll have 2n plus 2. So here you'll have simply 2 into 0 plus 2. So that is integral 0 to 1 2 dx plus integral 1 to 2. So here you'll have 2n plus 2 where n is equals to 1. So this is simply 6. Sorry, n is equal to 1. So this is simply 4. So 4 dx plus integral 2 to 3 6 dx plus and so on, integral 999 to 1000. So now you have to put n is equals to 999 here. So you'll get 2000. All right. So this is what you have to compute. So the value of this integral is simply 2. The value of the next integral is 4. And the next is 6 plus and so on plus 2000. So if you take 2 common, you'll get 2 multiplied by 1 plus 2 plus and so on plus 1000. So this is simply 1000 into 1001 by 2. So this and this gets cancelled. So your answer is simply 1001 000. So that's all for this session. I hope you have enjoyed solving this question. So if you have any queries, comment section is a way to reach out to me. And also there are a lot of fantastic videos on the channel. Make sure you check them out. So if you like this video, give it a thumbs up, share it with your friends, and subscribe the channel for more such content. I'll meet you in the next video. Till then, take care.